Welcome to EducAgent Studio, where a crew of AI agents help us teach and you learn with ease. Here's the problem we'll solve today. We will compute a squared and a cubed for each of the matrices A1, A2, A3, then use the pattern we see to predict a general formula for a to the n for any integer n greater than or equal to 1. This matrix is upper triangular. The diagonal entries will be easy to track in powers, and the main mystery is how that upper right entry grows. Multiply entries. The bottom left stays 0, bottom right stays 1, top left is 2 times 2 equals 4, and top right is 2 times 1 plus 1 times 1 equals 3. The same structure persists. Top left doubles to 8, and the top right becomes 4 times 1 plus 3 times 1 equals 7. Let's line up the first few powers to spot a pattern. The top left goes 2, 4, 8, which suggests 2 to the n. The bottom right stays 1, and the top right 1, 3, 7 is exactly 2 to the n minus 1. So our predicted general formula is this. Everything is the same here. This strong symmetry often makes powers collapse into a simple scaling rule. Each entry is 1 plus 1 equals 2, so every entry of A2 squared becomes 2. Therefore, squaring A2 doesn't change its shape, it just multiplies the whole matrix by 2. Now we use the shortcut. Since A2 squared equals 2A2, multiplying by A2 again doubles the scale factor again. So every entry becomes 4. The multipliers go 1, 2, 4, which is powers of 2. So the general formula is 2 to the n minus 1 times the original matrix. Since the second row is 0, any power will keep the second row 0. So we only need to track what happens to the top row. The top left becomes a squared, the top right becomes a b, and the bottom row remains all zeros. Multiplying once more increases the power of a again, a cubed and a squared b, with the 0 row unchanged. Lining up the first few powers reveals a clear exponent pattern. The top left is a to the n, the top right is a to the n minus 1 times b, and the bottom row stays 0 forever. Here are the 3 final formulas. Each one comes from computing a squared, a cubed, and spotting the repeating structure. The main insight is to watch which entries are forced by structure, like diagonals and triangular matrices, repeated rows, or 0 rows. In the next video, we'll learn a powerful viewpoint that explains these patterns systematically, so you can predict a to the n even faster. Watch the next one and keep going.